Hello Math 7 students, this is Utah Middle School Math Project Lesson 4.1b. We're looking at equivalent ratios and proportional relationships, and our focus for this lesson is on the constant of proportionality. Before we get started on this lesson, let's go over our quick poll warm-up. Students online, pause the video to answer this question. What is the constant of proportionality given this table? Pause the video and return when you're ready. Students in class have already answered this question, and now they're ready to tell me, how does a 1 change to a 1.5? Whenever there's a 1 on the table, that's the place to look. Jada, we multiply by 1.5. Does that work everywhere else on the table too? 2 times 1.5, is it 3? Yeah, and 3 times 1.5, is it 4.5? Yes. So everywhere on that table, all I have to do to go across the table is multiply by 1.5. So I would say the constant of proportionality is 1.5. That's it. It's just the number. By definition, the constant of proportionality is a number we multiply by. So when I'm asking what's the constant of proportionality, I'm saying, what is the number we multiply by? And you would just need to say 1.5. So here is what you need to take away from this experience. Once you think you have the constant of proportionality, then test it out. If you think that it's 1.5, then you have the rest of the places on the table to test it out. So you could type into your calculator 2 times 1.5. Does it really give you 3 like it's supposed to? Type it into your calculator and see if it does. 2 times 1.5. Does it give you 3? Chandon? Yes, it does. So it did work at least one other spot. Let's check one more. 10 times 1.5, does it give you 15? Okay, so does it work? Yes. And that's how I can confirm that it is 1.5. I had a lot of students tell me that it was 0.5. So test that out. Does it work? 10 times 0.5, does it give you 15? Nope, it doesn't. So that's why it's important to check it. Once you think you know it, check it, because it was not 0.5, as some students said. Okay, now let's look at the lesson. The first part of this lesson is actually quite a bit of a review before we lead into the connection to constants of proportionality, because I want us to tie in together all the things that we've done in the past with equivalent ratios, tie it into unit rates, so that we can more easily use and work with the constant of proportionality. So we start with an example, and most of this example is worked out for us, but they work out these examples using these diagrams here, which are tape diagrams or bar diagrams, bar models even. And we've always shown our work in a different way. So again, I just want to make those connections on how all of this works together. It says, use a model to determine how much money per hour you make if you make $42.30 in 5 hours. Here's the way that they solve the problem. They made a diagram showing the $42.30, and below it they put the 5 hours. And they said, well, let's see, we've got 5 hours. We need to split that into 1-hour groups. So they physically drew it out, split it into 1-hour groups, and since they split the hours into 5 groups, then they also split the money into 5 groups. Here's how we've shown our work, because we've done problems like this too. We would write it as a ratio, $42.30 in 5 hours. And where it says how much money per hour, that tells me that I want to change the 5 into a 1. And we know how to do that. How does that 5 change into a 1? Oh, that's right, we divide it by itself. So, yes, or multiply by 1/5. Very good. So whatever I'm doing down here, I need to make sure I'm doing the same thing to the other piece of that ratio. 42.30 divided by 5. Type it into your calculators if you need to. What did you get, Emma? 8.46. Weird. That's the exact same number that they got too. That's not that weird, is it? Okay. So the 42.30 divided by 5 is $8.46. You have a choice. Which way do you like showing your work? Do you like drawing out the whole entire bar and then redrawing it, splitting it into 5 pieces? Or do you like just writing it as a ratio? I do too. And the reason why I like writing it as a ratio, one, it takes a lot less space. Two, it takes a lot less time. And three, it's so much easier to continue this little chain of work that we have and re-copy it down again and again and again. Let me show you what I mean. I'm not even going to rewrite this because I have the ability to just copy it and paste it. Maybe. I know, it is a little bit. But I just want to show you, like, once you've done it this way, you can reuse that same information again and again and again and again. Like when it says, what if we want to know how much money we're going to make if we work 10 hours? Can we turn a 5 into a 10? Can we turn a 1 into a 10? Easily. No matter which way we choose to do it, we can easily turn either of those numbers into a 10. So what did they do? Well, they redrew the whole diagram showing 10 hours. What are we going to do? We're just going to change a 5 into a 10. How does a 5 change into a 10? We double it. So we're going to do the same thing here. Double that. And $42.30 doubled. I hope you don't need to type that into your calculators. Do you? Maybe some of you. You get 84.60, right? Yep. So again, could you have drawn out this bar model? Sure, but this is a lot easier. And it's especially helpful that we've already been through this when we get down to this problem. And yes, I just copied and pasted it again because I want you to recognize once we find that unit rate, it's so much easier to reuse it again and again and again. The next question says, now let's figure out how much money we're going to make if we work 3 hours. Can you turn a 5 into a 3 very easily? No, not as easily, but it's a good thing we don't have to because we already changed the 5 into a 1, and now we can turn the 1 into a 3. That's why it's so helpful to find the unit rate early on in the beginning, because then we can reuse that unit rate again and again and again. So that 1 is multiplied by 3, so the $8.46 is also going to be multiplied by 3, and we get, anybody? Here it is, $25.38. So, unit rates and equivalent ratios, making a connection here. Now we're going to take all of that information that we just did in the last parts, A, B, and C, and we're going to put all of that information in a table. Notice that it's already done for you, but it did leave a couple of blank spots. Fill in those blank spots. Work with your groups. Figure out what the constant of proportionality is so that you can figure out what goes in those blank spots, or you can use this information here and work it through that way. 60 seconds is all you're going to get. Ready, set, go. $15 seconds left. Can we get that whole table filled out? Yes? Not yet, not yet. Now, because the timer just went off. Okay. How did you fill out the table? Did you by chance look at this and say, I know how a 1 changes to an 846? Anyone do that? Okay, how does a 1 change to an 846? We multiply by 846. Now we know the constant of proportionality, so we know what we're going to be doing every single time in that table. So what am I going to do with this 2? Multiply it by 846. And what am I going to do with the 4 here? Probably multiply it by 846. And what about the 8 down here? Yeah, I think that's a good strategy. But what do I do with this 126.90 down here? Jada. We would divide by 846. And so now you know those calculations, so if you haven't already done them, you can. And 2 hours, how many dollars are you going to be making? Thank you for those hands, Trinity. Oh, right answer, wrong question. 2 hours, how many dollars? CJ. $16.92 or $16.92. And 4 hours. Sam. You got it. And 8 hours. Bryn. $67.68. And now Trinity, $126.90 would be 15 hours. Yep, we got our calculations. Now our table is complete. And now we're going to highlight a little bit. So get out those highlighters. If you don't have highlighters, just underline. Do it quietly because I'm going to keep on talking. This table is a collection of equivalent ratios. And we've already been through this and talked about this. When we have a collection of equivalent ratios, that's called a proportional relationship. This right here, this is 6th grade terminology. But we are not in 6th grade anymore. We're in 7th grade. So we use 7th grade language and we say proportional relationship. But we don't need to be scared of that big word, proportional relationship, because it just means equivalent ratios. And we showed our equivalent ratios up here, but we can also organize that same information in a table just like we've done here. And the reason we do this is when it's organized in a table like this, it also helps us see relationships that maybe weren't as obvious before, like we can multiply by $8.46 as we go across that table. So, more highlighting, next page. A proportional relationship is defined by a constant number that associates the quantities in a proportional relationship. It is a constant number. That constant number is called the constant of proportionality. Have we heard that word before? A few dozen times. We also might call it, usually I call it constant of proportionality, but sometimes I switch it and I say proportional constant. Same thing. Constant of proportionality or proportional constant. And here's the part that gets to be a little bit weird and tricky. Because it says it relates one quantity to another with their quotient. This word quotient, what does the word quotient mean? Chandon? Oh, close. That would be a product. Quotient means... Dakota? Nope. You guys, I like it because you guys are really understanding what I've really tried to emphasize. And what I've really tried to emphasize is the constant of proportionality is the number we multiply by, right? But that's why this is a little bit confusing, because what does quotient actually mean? Emma? Nope. Quotient means division. So do you see why this could be confusing? Because I've emphasized so many times, I went the wrong way, that the constant of proportionality is the number that we multiply by. And now it's saying, oh yeah, PS, quotient, division. So we've got to clear up this confusion. We've got to understand why this is telling us it's the quotient and why I've always focused on the product when we multiply. So let's continue to read, and then we're going to go back and look at that example again. It says, in the example above, the proportional constant was 846 because we multiply the number of hours by 846 to get to the number of dollars. And that's what I've always said. It's the number that we multiply by. Well, how did we find that? How did we find that 846? We found it by looking for the quotient. Sometimes it's really easy, like in this table, where we say, how does the 1 change to an 846? That's easy, right? But if it was something that we didn't know, like we saw in our previous examples or like we saw in our homework, if we don't know, like all I have is this information here, how does a 5 change to a 4230? That's not quite as obvious, is it? And so that's when we would have to do division to work backwards, which, believe it or not, we actually did. We did it here. Didn't we? We had 4230 in 5 hours, and we said, well, let's find the unit rate. How do we change a 5 into a 1? We divide by 5. So we take the 4230 and we divide it by 5. But notice what we ultimately did. Take a look. I'm going to highlight again, but I'm going to highlight in a different color. What did we do? We did 4230 divided by 5, right? I don't know if that's a good color to highlight. Let me try blue, green. We'll go green. 4230 divided by 5. That's what we actually typed into our calculator. But do you see that already here? What does this say right here? 4230, not over 5. What is this right here? What does that mean? That means divide. So didn't the problem say that from the beginning anyway? Yep, it did. So really, truly, we're finding it by doing that division. We're looking for the quotient. We kind of disguised it by finding the unit rate, but it still is that same process. So when we don't know how to go forwards in a table, we go backwards by dividing. And so that's where that word quotient comes from. But then once we divided, like we did up here, 4230 divided by 5, we got 846. And that was our magical number that we reused here again to go across the table. So we can find it with division, but then how we use it is by multiplying as we go forward. So make that connection. We find it by dividing when it's hard to know how to multiply, but then we use it by multiplying. And now with that in mind, we're going to end this video. Although there is some more for this particular lesson, I want to just focus on recognizing that relationship between the constant of proportionality and that unit rate. We find the unit rate with division, but that unit rate is the same as a constant of proportionality. And then we use that constant of proportionality to multiply as we go forward across the table. We'll finish this lesson in the next video. That's it for today. We'll see you next time.